LINQ is a popular language feature that we have access to in C#, and it helps us tremendously when we're working with enumerables and different types of collections. But what if you wanted more? What if you needed more LINQ? Hi, my name is Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In this video, I'm going to introduce a series on the NuGet package called MoreLINQ. One of the maintainers of this package approached me and said it would be an awesome opportunity to give it a little bit more coverage because LINQ is so widely used, and if you go check out this package, it has millions of downloads as well. Now, there are tons of different extension methods and things that you can use from this package, so I can't obviously cover them all in one video, but we're going to start this video off with batching. If that sounds interesting, remember to subscribe to the channel and check out that pinned comment for my courses on DomeTrain. And with that said, let's jump over to Visual Studio and check out batching from MoreLINQ. So as you can see, I'm using MoreLINQ here. This is the library that we're going to be talking about, and I'm using version 4.3. MoreLINQ has been adding extension methods over time, but of course, as C# and .NET are evolving as well, there have been extension methods that have been included into what we have access to by default. So there are things that get added into MoreLINQ, and then all of a sudden, maybe it's a couple years later, we just get them for free as part of .NET. But there are still tons and tons of extension methods that we don't get for free, and they're included in this package. So with that said, batching is going to be what we're looking at in this video. And to start things off, I'm going to walk through this very brief example, and then I want to dive into some performance characteristics if we wanted to go implement this ourselves. Batching is going to take a sequence, so a collection that we're working with, and it could just be an enumerable, right? So if we go look at the batch method here, it is an extension method that works on IEnumerable. You don't need a materialized collection like an array or a list necessarily. It could be from an iterator, something that's generating different data for you. And in this case, what I'm doing is I just have this array declared here on line 3, and then I'm going to be batching it by 3. If you haven't really thought through what batching might mean, maybe this is brand new to you, the idea behind batching is that we're going to break this up into different smaller pieces, and because I'm using 3 here, it should be taking this first batch of 3, and then this next batch of 3, and then this next batch of 3, and then the final batch that we'll have won't be of 3 because there's only 1 left, but it will be 1 element in the final batch. And you can change the batch size, right? So if you did a batch of 1, for example, the batch size being 1 means we're just going to take one single element at a time. And if you were to make the batch size 10, that means, or I guess, yeah, it is 10 in this case. So because there's 10 numbers, I didn't start at 0, I threw myself off. With the batch size of 10, you're going to get one batch, and it's going to have all of the numbers in it. So to walk you through with a size of 3 for the batch, what I'm going to do is just briefly explain this for each loop is going to go over this result. If I hover over it, you can see that the result is an IEnumerable of integer arrays. That means that the integer arrays, each one of those is a batch, and in this case, we're going to have sort of an IEnumerable of those. Like we see very often in LINQ, we end up getting IEnumerables as the result of the different LINQ methods we're calling. And that allows us to kind of get this pipelining effect so that you can, you could do batch and then you could do select on here, and you're still going to be operating on an IEnumerable as you continue this on. So we get an IEnumerable of arrays of integers. And just wanted to kind of call that out, that it's going to be an IEnumerable, but each element within that enumerable is an array of integers. So if we think about the code we have here, if we wanted to go print out every number, it makes sense that we're going to need 2 for loops, right? Because we're going to have one that walks through all of the batches, and then this inner for loop, so that's going to be from line 9 to 10, that's going to walk through each number that's in the batch. So hopefully that makes sense. The way that this code works is we're going to just put each batch, the numbers in it across a line, and then we're going to have a new line to go for the next batch. So if I go run this, again, 10 numbers, batch size of 3, let's check it out. Before we move on, this is just a reminder that I do have courses available on DomeTrain if you want to level up in your C# programming. If you head over to DomeTrain, you can see that I have a course bundle that has my Getting Started and Deep Dive courses on C#. Between the two of these, that's 11 hours of programming in the C# language, taking you from absolutely no programming experience to being able to build basic applications. You'll learn everything about variables, loops, a bit of async programming, and object-oriented programming as well. Make sure to check it out. All right, if we check out the results here, we can see that we have 4 lines, and the first batch is going to be 1, 2, 3, so you might have guessed, right? And then we have 4, 5, 6, 7, 8, 9, so each line itself is a batch. And then finally, we have 10 on the last line, and there are no other numbers that get printed with 10 because it was the last one. We can't make a batch of 3 numbers when there's only 1 left. Very simple example, but we want to go check out the benchmarks now, because I think that's going to give you some other interesting thoughts, and I didn't want to just leave it very simple with here's how you go batch, even though it's pretty cool, because I think I've probably written code that does batching many times, and I've never thought to just go make an extension method and reuse it. So kind of cool that we have access to that. But let's jump over to the benchmarks. I am going to be using benchmark.net, and hopefully as I continue to build out this video series with other MoreLINQ extension methods and things that we can use, I can just keep adding more things into here. I'm just starting this one off with batching, but if you're not familiar with benchmark.net, I do have other videos on this. You can check them out on my channel. Literally just search benchmark on my channel and you'll see a whole bunch. I'm starting with the benchmark switcher, which allows us to, when we go run this, bring up a console app that lets us pick the benchmarks that we want to go run. Because we only have one in this case, not very exciting, but as I build it out, we'll have others to pick from. The batching benchmarks that I want to look at, I'm picking different collection sizes because I think it's really important to see when you're dealing with a very small number of items versus a very large set of items, what kind of characteristics do we start to see, right? Does it kind of scale linearly? Do we have some weird cutoff point where we have some differences showing up? And then I'm going to look at batch sizes as well. And if you haven't used benchmarks.net, you can kind of think about this as being, you multiply these together to kind of build a matrix of the different combinations of things we're going to be working with here. We will get batch sizes of 1, even though we'll have, a collection size of 10 and 10 million, and we'll also have a batch size of 1 million in some cases and only 10 things in the collection, right? So what do we expect to happen in that case? So we'll go through these benchmark results after, but I just want to walk you through how this is set up because I do think it's important that I don't just show you a handful of results and you go, that's cool, Nick, I don't care. Maybe you do care, but I want to show you how to do this so that you have the tools you need to go benchmark your own stuff, right? I think there's other lessons to be learned along the way. So I have this global setup for my benchmarks here. This is just going to create the collection. You can see enumerable range. I'm going to make it an entire array. So we will have a materialized collection in some cases when we go to run these benchmarks of up to 10 million items in them. So we're going to go make that. It's just going to be an array of numbers that are basically all 0 by default, right? So not that exciting, but it doesn't really matter in this case because we're just trying to break up the array into different pieces. So what I'm going to do is, and I'll explain each method a little bit more in detail, but I'm going to compare manual batching, but using a materialized collection. So when I was explaining how batching worked from MoreLINQ, I said it's going to be an IEnumerable of integer arrays. This one will be an array of arrays. So we're going to have a collection of collections. The next one down here is going to be manual batching, but streaming. So it's a very naive approach to trying to build what MoreLINQ is doing. So when we go to look at manual batch streaming implementation, we'll see that I'm basically trying to go do my own version of batching, thrown together very quickly, no optimization attempts. And it'll be interesting because when we go to check out this next one here that does MoreLINQ and using batching, should we get the exact same results? Did I happen to implement it the exact same way? Or did they manage to do it faster and have a lower memory footprint? Which reminds me, if I scroll back up here, you can see that I did add the memory diagnoser attribute on here. So when we run these benchmarks, we can see what kind of memory we're allocating. To go down a little bit lower and look at some of the implementations here, I guess I did say that it's going to be an array, but that's not actually the case. So this is going to be a list internally. So manual batching streaming is going to have an iRead-only list here. The only reason I did that was just to kind of take a shortcut because I'm resetting the collection inside here. You'll see that I go through here, and then by the time I get to here, I'm just making a new list with the batch size. So this creates the batch itself, and then I yield back the batch. So this sounds kind of weird because I think sometimes when we're thinking about building iterators, it's kind of like a single dimension that we're going through. But I need to go create a batch, and then when I'm done building the batch, I need to go yield that whole batch back up to the caller. So sounds kind of weird, but then I'm just going and recreating this. I guess technically I could go make this an array. I'm just kind of thinking about this on the fly. So this could be something like an integer array, like that. And then I wouldn't add, okay, no, that's why. See, I'm debugging this on the spot and I shouldn't do that, but the reason that I'm not doing that, and it would be pretty easy to go fix, is I just have to keep track of how big the batch is, which is kind of interesting, but if you think about the first example I showed in this video, when we were walking through batch size of 3, that last batch was a size of 1, right? So if I used an array and it was a fixed size, I would need to indicate that that final batch needs to be a different size. So it's very doable, but it's kind of cheating just to use a list and make it quick. So like I said, this is a quick and dirty way to do it. It's not optimized, just threw it together. This last part takes care of if we have a final batch that hasn't been yielded back, so we will go do that. The next one is going to be materializing it. So this is where I was saying, I think a little bit earlier, I mentioned it's going to be an array of arrays. It's going to be a list of lists, which is fine. Very similar. It's not going to be that big of a deal. But again, it's just because I'm taking shortcuts. You could absolutely build this with arrays. Not really that big of a deal. Same concept, but instead of yielding, you'll notice this is not an IEnumerable, right? And that means it cannot have yield in here. The reason I wanted to walk through this is, again, because I've made other videos about showing you the performance characteristics of iterators versus collections, and I just wanted to be able to illustrate some pros and cons that we have with doing that. So what we should see is that we have a lower memory footprint when we are basically streaming data with iterators versus fully materializing them. Now, with the batch, so each thing that gets yielded back, that is going to be a materialized collection. But we are streaming back batches in some cases, and in this case, we're fully materializing all of them and then returning that whole thing back. So just to kind of elaborate on what that does. Now, the MoreLINQ one, if we go up to this right here, this MoreLINQ batching, I don't have, like, I'm not looking at the code for that. I'm just calling batch. So one of the advantages with using MoreLINQ is you don't have to go write these other methods, and hopefully they've done a good job optimizing it. So in this case, because these are going to be yielding things back, I'm just keeping it consistent with iterating over the entire set. Do we need to do this necessarily? No, but I wanted to make sure that I just had something that would walk through all of the numbers, and like I said, just for consistency as we go through all of this. That's enough blabbing about the code. You probably want to see the benchmark results. So instead of making you sit here for 15 minutes, I'm going to go get those generated, and then we'll walk through the numbers together. My video editor will do a great job and make sure it's all cut out just for you. All right, the results are in, and fair warning, get ready for a wall of color. So when we jump over to look at the benchmark results we have here, you are going to see a whole lot of numbers, of course, and the columns unfortunately didn't get printed out properly, so they're kind of wrapped around, so it's a little bit misleading. So as we go through these, I just want to highlight the columns that I want us to be focused on. So the first two columns after the name, of course, are going to be the collection size and then the batch size right next to it, okay? So collection size, then batch size. The next one is going to be the mean. So this is going to be our performance number that we're looking at in terms of the runtime. So this column, this sort of like 1, 2, 3, fourth column over, this is going to be one that we're very interested in. And the other column that I want us to be paying a lot of attention to is this final column, which is going to be the number of bytes that are allocated. Obviously, there are more numbers in the middle here. I'm not saying that they're not important, but the ones that we want to focus on are the ones that I just called out. At the beginning of our data sets that we're looking at here, we are going to be dealing with a smaller collection size and then kind of stepping through the batch sizes as they increase. Starting with a collection size of 10, which is our smallest. Really, this is just trying to highlight that if you're working with small sets of data, because I think a lot of the time when we think about performance characteristics, we're trying to push to extremes, right? We're saying, okay, if I want to go load in all these records and stream all this data, what's going to happen? But we also have scenarios where we're dealing with small amounts of data, and maybe we have small amounts of data, but it's a hot path in our code. So I do think it's important to look at even small data sets. So when we start talking about a collection size of 10, really the only paging opportunity that's going to break things up is when we have a batch size of 1. We're going to have 10 different batches in that case, but all of the other ones should really result in a single batch that comes back, right? So just wanted to kind of call that out. But if we have a look in every single case here in the beginning, so if we look at the performance numbers in the mean category, we can see that we have 54 nanoseconds for basically every single entry for MoreLINQ. So it is significantly faster than my naive approaches. I was kind of expecting this. I didn't go through their code and see the optimizations and stuff they made. I certainly did not try and optimize what I wrote, but basically a whole order of magnitude faster in the first case, which is treating every element as its own batch. The next case, where we are basically doing just one big batch because the batch size is bigger than the collection, they were still the exact same runtime, right? So 54 nanoseconds again, still a whole order of magnitude faster. Once we go beyond this, you can see that the performance of my code was significantly worse, right? So in that case, they're basically 3 orders of magnitude faster than mine, which is pretty embarrassing for having a naive approach, but still. And then you can see it gets even worse, or I guess from their perspective, even better for performance. But it doesn't stop there, because if we jump all the way to the last column and look at the allocation, again, the column header is missing, but the last column's allocation, you can see that they're an order of magnitude better in terms of bytes allocated than I was in basically the first 2 scenarios. And then again, after that, they're significantly better. They don't increase their allocation footprint, even though we are changing the batch size. So you might be wondering, well, Nick, how is that possible? Like, why is it that my implementation, the size was going up so much? And that's just because technically the small, like I'm going to use air quotes here, small optimization I was using was setting an initial collection size. So technically that's doing some pre-allocation there. So in this case, it looks like that was just really not working. So maybe something I could do as an optimization, like I mentioned, was using arrays, just using one single array, allocating it once in at least some of the situations where I'm yielding it back. So that might have been better versus making a whole new list. Maybe I could have kept one list and cleared it each time so it had the same capacity. A bunch of different things that could be explored there, but like I said, mine did not attempt to optimize, just wanted to get something in place. Let's go a little bit further and see if we're going to start moving through this a little bit faster now that we walk through one in detail. But when we start looking at the 1,000 collection size, right, you can still see that in the first case, where we are basically treating every single element as its own batch, right? Because a batch size of 1, every element is its own batch. MoreLINQ was, quite fast, an order of magnitude faster than mine. What's interesting is we jump to the next one and we look at the performance. When the batch size was the same as the collection size, my implementation did reasonably well, especially compared to MoreLINQ, which is interesting. So you can see here there's 3,000 nanoseconds, and I was 3.5 in the one materialized implementation I had. So kind of interesting, very comparable. If we go look at the allocated column, so that would be over here. Just trying to, this is a very long row. I just want to double check. So we go check this out. They're definitely, like, they're half the allocations that I have. And if we go back to the previous one, right, so the row that was right above, we can see that they just completely decimated mine in terms of allocation. But the thing that I wanted to call out here from the allocation side is that they're very consistent. In mine, it kept changing. In theirs, they're very consistent. If we go back to the performance column, basically they continue to be very fast. It's again very consistent with their performance, but mine is not scaling. As we keep going up in terms of the batch size, mine keeps getting worse. I suspect that because I'm not doing more iterations, like I'm not scaling based on the iterations here when the batch size is increasing, I suspect there's something going on with allocating a list and trying to give that the initial size. So probably some type of overhead that's happening there. That's my speculation. Jumping down a little bit further, like I said, we'll keep going faster and faster. The runtime of my manual batching materialized one is awful. It's absolutely awful if we look here. If we compare it, my implementation where we're materializing the entire set versus just streaming, it's an order of magnitude faster to stream back the different batches. It's an order of magnitude faster. And theirs is an order of magnitude faster than mine. So they're definitely doing way better than me, which is totally cool. The reason I'm highlighting this as well, right, is like, it's not wrong to roll your own solutions to things. Definitely not. You know, there's considerations if you want to go add a dependency on a whole package. Sometimes at companies, you're not even allowed to do that because they have constraints around that. Many reasons why you could or why you may not go include a package. So again, it's not right or wrong, but when you have a team of people that's dedicated to making something really good, you can see that it ends up paying off a lot of the time, right? So again, if we jump over all the way to the allocated column, it's relatively consistent after the first block here. Like mine was pretty rough, but if we jump down and kind of scan with our eyes a little bit lower, mostly pretty comparable in terms of allocations, which is interesting. And then in the final set, they have again half the allocations that I did. So mine doubled in the end, but theirs remained consistent, which is very impressive. Overall though, the performance, once we started getting into this territory, theirs was faster every time. So theirs is faster, but not orders of magnitude like we were seeing before, which is interesting. In fact, actually, this one that I had when we were doing the materialized one, interestingly enough, the performance of mine was faster. You know, this next one compared to theirs is almost the exact same, kind of like how this one is too. But like mine is a little bit faster, kind of snuck in, which is unexpected from my perspective. If we look at this one, let's kind of jump across all the way here. I guess I did allocate a little bit less memory as well. So not sure why. It's a bit unusual. It kind of feels like an outlier to me because everything else does not show this pattern. So I did manage to allocate a little bit less memory, and I did manage to go, at least in one of the cases, a little bit faster. So kind of interesting there. If we jump down even to the next set, right, where the batch size is that the same? The batch size is not the same. So still doing batching. I guess it is the same. No, I can't count. There we go. The batch size is not the same. And if we go across, theirs is still more performant. You know, in this column here, that's the best speed, and over in the far right column for the allocations, theirs is still better. I have like one outlier so far. My money's still on MoreLINQ for batching at least. And if we go to this last bit again, my performance for doing a materialized implementation is just terrible. It's significantly faster to go stream it when you have such a disproportionate amount of individual batches that you have to yield back. So that's sort of one thing I want to highlight here that's not really specific to MoreLINQ, just kind of this design approach in general. But even so, theirs was much, much faster. If we quickly scan through the numbers, theirs is very consistent. In fact, it's kind of interesting. It almost speeds up as we're going through, which I guess that makes sense. There's way more iterations when you have to go yield back all of these little batches. So I guess that does make sense. It's speeding up, but overall very consistent from their perspective. I just wanted to double check if I have any others that happen to beat theirs out, and no. I think out of all these benchmarks, unless I missed it as I was going through and you're watching and you notice, I only had the one set of benchmarks that went faster. And I think it's a fluke, so I don't really want to trust it. If we check the memory column, actually this one that I had down here, if we look, we can see that I had a little bit less for allocations, but theirs was faster. The difference in allocations is not really that significant. The one above, I also had less allocations, right? So these two numbers are smaller than the third one, but theirs was faster. In fact, this number here is a little bit greater than this number here for allocations, but it was half the runtime. I mean, you're trading a tiny bit of memory here, but significant amount of runtime performance. So overall, these benchmarks definitely suggest that they are quite memory efficient, which is very impressive. Performance basically blows mine out of the water in every single case. So again, just want to highlight, if you're relying on a team of people that's building a specialized set of tools, if they're supporting it, which these folks are, it's definitely been downloaded a tremendous amount and highly supported, I think you're going to get a good result. So overall, that's going to be batching. It's from MoreLINQ in this case, and it's just giving you the ability to take a collection or a stream of data and break it up into smaller chunks. and that's going to be based on your batch size. But that's going to wrap this video up. I hope you found it interesting, and there are going to be more videos in this series, so when those are ready, you can start watching them up here. Thanks, and I'll see you next time.